Hello guys, welcome to the Me Squared That Crash Course. And today we're going to be talking about a very interesting topic, which is actually mixins in that. Okay, um, not everybody kind of like uses that. Okay, but they are very um essential and important concept in that. So mixins are like separate entities that you bring um not that you bring but that can bring functionality to existing classes, right? It can be either to classes or enumerations, and in that way you can have in like multiple inheritance, because we do know that that doesn't support multiple inheritance. So but through mixins we can be able to accomplish this behavior or this pattern. Okay, so without further ado, let's dive into the code and let's explain. So we are going to do the usual dance. Okay, we are going to create a folder. We're going to call it Mixins, okay, because mixin is actually a reserved word in Dart, but let's just go ahead with mixins. Okay, and we are going to create a first example as usual. Example 1.dart, okay, and we are going to open that in the terminal. Without further ado, zoom in a little bit for so that the even though some mobile devices can be able to see. Okay, so we're going to start with the first example actually, main, and here we are going to define a mixin called mixin has speed, okay. And actually, this is the syntax, okay? To define a mixin, you just say mixin, and then you give it the name of a mixin, okay? Using the Pascal, I think there's a Pascal case, and then your curly braces, and whatever you want to write goes in between. So we're going to go with abstract, not abstract protected, abstract double, say speed, okay? We're going to also create another mixin called mixin. We're going to say can jump, okay? um and we're going to say this void, we're going to create a function on it, void jump, okay. And this void jump we're just going to require, I think we should require some parameters here. Require double speed so we can know at which speed we are jumping, and then we're just going to print a simple statement here saying runtime type is jumping, at the speed of dollar speed, okay. That's nice. Now what we're going to do here is that we're going to mix another mixing into another, if you kind of like understand what I'm trying to say. So what I'm just getting trying to say is that we're going to build this can jump on top of has speed, so we're going to say on has speed. So after doing this, now we are going to say this dot speed, okay, is equals to speed. So this dot speed refers to this speed here that we are talking about. You see, even when I right click on it, it highlights both of them. So this speed and this speed we're talking about is what we are getting in from the function as the parameter, okay. So we are now going to now also create another mixing, say can walk, okay. So it's basically going to be the same thing, just say can walk, and then we're going to say walk. Our runtime type is walking at the speed of this, and the same implementation. So we have spoken about classes, right? So we should be familiar with how to create a class, okay. And I'm just going to create a normal person class, say person here, nothing really much, okay. And this, now the way we can now um, bring up the concept of multiple inheritance with classes is by using with mixins, is that we first of all use the with keyword, okay. So we don't say extend, okay, we say with when it comes to mixins, and we say has speed. And you see, if we just put has speed, it's going to say missing concrete implementation of the has speed getter, okay, because of this abstract class that we implemented here. So we have to provide its implementation. So we go ahead then and create the override missing that using I think I always like having my constructor at the end. With that, okay, so there are basically a couple of things we can do. We can initialize it here saying 0.0 as a double, or we can just initialize it at the point of construction saying speed. That means immediately as the constructor gets called, gets constructed as well. So we now have this. We can now go to our main function. Okay, we can now go to our main function, say final person is equals to person, create a person, and I will say person dot jump. Okay, jump. Okay, so now this is just what I wanted to talk about. So here you actually see that we don't have the jump function available on the person while because of the multiple inheritors that I spoke of, right? Remember that this person class is inheriting only from the has speed mixin. It's not inheriting from the can jump because this jump function is found in the can jump mixin. So we will need to then add it here to the person's class, which is of course can say can jump, and of course we will also need to add the can walk as well. Not jump actually, again walk. So now you see now jump is not available and it says the name parameter speed is required. So we now provide the speed. Okay, so we say speed and let's just say 10. I don't know, it could be anything, 10 kilometers. I mean, and here let's say something like 8. So here we're going to say walk. Okay, and if we try now to run this code, okay, and dart example 1 dart. Okay, now we get this person is jumping at the speed of this, and this is jumping at the speed of this, walking at the speed of this. So let me bring this down a little bit. So basically this is it, right? So this is how then we make use of the mixing. So we're not just going to stop there, we're going to continue, and we're going to move to example 2. Okay, and the usual then example 2 dart. Okay, and in this example 2 we're going to be talking about mixins and functions, right? Mixins are data types themselves, right? And we can accept a mixin into a function, right, as a parameter into a function. So we're going to see that. So main, so we're going to create a mixin, has first name. Okay, this is just a mixin to just say string get first name. Okay, and then of course you can imagine that we have also a mixin for has last name. Okay, has last name, and we will now have a mixin that will be, should I say, built upon these two, that it will be has full name and it will be built upon has first name, if we can use that, and has last name. So now it will have its own getter, which is string dot get full name, but this getter will be returning to us dollar sign first name. Okay, so you see the first name is available to us because of this let me say this mixin inheriting from the has name. Okay, so we're able to have that, and then last name and semicolon. Okay, so from here now we're going to now create a person's class. Okay, again I think I should just go to example 1 and just copy so we avoid wasting time, and we can come here and then paste this. Oh, this is something my IDE usually does, kind of like freezes. Let me try to close this out and open it again. Oh, it's still there. I just have to completely reload my Windows. Okay, so without that, now we can go ahead and now paste the person's class, and we can remove this. And this, now we are going to provide we're going to remove this, okay, and also this. So now with this person's class, what we're just going to do here is, as we did, right, multiple inheritance. So we're going to say with has first name and has last name, okay. And now you see it says missing concrete implementation of getter as first name, first name. So all what that error was just trying to say is that we haven't provided, we are inheriting, but we haven't provided the implementation of this last name and first name. So we are going to go here and create a missing overrides. Okay, remove the to-dos, and also remove the true implementation, okay, and remove this. So we are going to provide a constructor, a person class constructor. So person, okay. So now we are getting here this error that first name must have a method body because person isn't abstract, right? So it's a class. So basically what the error is trying to say here is that, okay, we are provided this value, right? So we need to provide its body for it, because actually this is a getter, right? It needs to have a body, but we are going to bypass that by saying this is a final property, okay. This is a final, and with this now we can now provide add formal, and I think, can I do this? Okay. And with this we're going to add, no, this, and we're just going to add the required keyword in front of them. So basically, let me explain what I'm trying to do here. So basically what's happening here is that we have a string, right? So the contract here is that this has first name, it's a getter on the first name, right? And in this class what we're doing is that we're providing a final property, so we haven't breached our contract, right? So this has fit is still saying that, okay, okay, so this is what they're actually saying. So hey, so we're saying like, hey has first name, we have this property here that is called has string first name that you can use, you can read from, because that's what the get actually does, right? It reads from. So it's going to say, oh, okay, so you have this first name here so that I can read from, right? So that's actually what we're doing. And then we are now creating it here with this person's constructor by getting the first name and last name and then assign it to here, and which this first name and last name can read from. So I think we should also add the has full name. Not even I think, we have to add the has full name. If not, we will not be able to oh, not here. Here on the person's class, we need to add the has full name. If not, we will not be able to get access to this getter property here, to this getter. So we now go to our main class, and what we're going to do here in the main class is that we'll construct a simple person. Let's say final, let me just call it Austin. Okay. Person, this person, the first name is going to be Austin and the last name is going to be Gareth. Okay. And basically that's it. So now we want to be able to print this, right? Remember we said this this example was all about functions and mixins, right? So we can now go ahead and create a simple function that's going to be returned to us a string. I'm going to say get full name, okay, get full name, and it's going to be an arrow function. So this arrow function, now what is it? We talked about receiving a mixin as a parameter. So now this mixin that we're talking about, that we want to be able to get a full name, is actually this has full name. So we're going to say the has full name, okay, and let's just call this an object, and what we're going to return from here is object dot I think it's called full name. Yeah, object dot full name. Okay, so this is what we are going to return from this get full name function. Okay, so we can now come here and what we can do is that we print. Okay, yeah, let's print that. So the first way will be first of all by saying Austin.full name. Now this full name is available directly to us on the class because remember we added it here on this person's class. If we were to remove it, okay, you see the greater full name isn't defined for the type person type import in the library and all of that error. So it's available due to the full name. The mixin has full name available on it. So now to be able to read from the function itself, then we still have to go ahead and print. Okay, print get full name. Now same as this object, this has full name, right? We pass indirectly Austin, right? So remember it conforms to the has full name because we're kind of like doing the multiple inheritance, right? So it conforms to this. That's why we are able to do the Austin, the get full name, and you say it doesn't complain as an object, right? And we're able to get the full name property on it. So if we try running that example 2 to that, okay, we get that Austin Garrett and Austin Garrett for both of them. Even if we were to try adding a print applying separator here, okay, and we got that cleared and we did this, okay, then we get that Austin Garrett and Austin Garrett. So this is basically how you can pass a mix into a function and have it done or execute whatever code you have in mind. So let's jump with example 3. Okay, so in this example 3, let's first of all go ahead and create that example 3 dot. Okay, so in this example 3 we're going to be talking about mixins with some logic, right? So we are going to get out a little bit of the usual and try to provide some logic to our mixin. So let's say we have a main. Okay, now we have a mixin and then we're going to say has h. With mixins, this is how you actually go most of the time, like with the has h and has feed, has can walk. Okay, so that's it. So say int h void increment h, which is a function, and it's going to have access to this h and then increment it. Okay, so we are not going to have a class as usual person, or let's have a different class. Let's say class dog with, we're going to call upon the has h. Okay, and it says missing concrete implementation, so we're going to provide a missing concrete implementation. So we're going to say it has an initial age of 0. Okay, because like normally every dog has an initial age of 0, then 1 and 2, and then that. So from there we provide a constructor. Okay, and we're going to say require this dot h. Okay, so basically we're not going to be doing anything much here, so we're not going to go to our main. We're going to say final wolf, okay, dog, and let's say we're going to say h2, and if we try printing wolf.h, okay, then we're going to get example 3, we get 2. Now we want to increment that h, so we're going to say wolf dot increment h, okay, and then we're going to print wolf dot h again. Okay, so let's try to provide a delimiter, something like a separator, so that we can see what's actually happening. So then we can now go ahead and clear that and then run example 3, and then we see it. So age, it's first of all 2, then now age is 3. Okay, so that's how we can also add a function in a mixin and try to use it by incrementing, by decrementing, and do some other fun stuffs with it. Okay, so with that said and done, let's go to example 4.dart. Okay, example 4.dart. So in example 4.dart, we can also limit mixins to specific data types that you want to be able to work with, right? So we're going to go back to creating a class. Let's start with our main function. Say class has 2 feet. Class has 2 feet, and just a simple constructor has 2 feet here. Nothing much. Then we'll create a mixin can run on has 2 feet, and then we're just going to say void run. Okay, print runtime type is running. Okay, so runtime type is running. Now if we try to go, so now what you should be now, I'm sure what you're expecting is that since we are doing this is kind of like strange, because we normally do classes on classes on mixins or classes with mixins. Let's use the with keyword, but now here we're doing a mixin on a class. So you would actually be expecting that maybe we can say final bar, okay, is equals to has 2 feet, and then we should say bar dot, but we can't see the run function, it's not available. Okay, so what we are actually trying to say here is that, like, let me put it this way, what they can run, or the run, what the run function is actually saying, or they can run, right? So it's like I'm available to any type that conforms to has 2 feet if that type brings me in, right? But I am not available on any other type even if they bring me in. And it's kind of like confusing at the beginning to be able to get it right, but basically what it's just trying to say is that if we create a class that brings can run in, that brings has 2 feet with can run, then we can be able to see the run function. But if we just bring in the can run, then we won't have that. Okay, so let's create a class human that extends has 2 feet. Okay, because let's try something. Let's say can run. Saying can run can be mixed into an object because object does not implement has 2 feet. So this is what I was trying to say. So you see now, if we try to just bring in can run, it won't go. It's throwing an error. So we need to implement the has 2 feet already. So that's what I was trying to say. That this is what. Let me repeat that sentence again. This is what it's trying to say. I am available. So can run is saying I am available to any type that conforms to has 2 feet, right? If that type brings me in. So for you to bring it in, you need to conform to has 2 feet. But I am not available on any other type even if they bring me in, right? So this is what this type is bringing. This is what this type is doing. It's bringing can run in, can run, and the can runner is not showing an error that it has to conform. So what do we do then? So we need to extend, okay, because that's a class. This is a class, right? This is a class. There's not a mixing, so we can't say with has 2 feet. So we say extends has 2 feet, then we can bring the can run, okay, and then we just provide a simple constructor for the human, and that's all. So now if we try, we can even go ahead and just say human, and then we now see the run function available. Okay, but now if we create another class, okay, if we create and we say has no feet, okay, um not that, if we say that has no feet, and we create a class called fish, not fish, and we extend has no feet, okay, and we say cons fish. Now you see that here we, if we say fish, okay, we don't have the run, right, because obviously the fish doesn't have a feet, right? So if we try to run this example 4 to that, and then we get that, okay, so we see human is running because human has 2 feet, and human conforms to has 2 feet, and then it brings in the can run mixing. Okay, so this is basically how you can intertwine a class and a mixing, or a mixing and a class, to have specific type of solid architecture code, okay, such that anybody who tries to implement this mixing must obviously conform to this class, okay. And if this class had some couple of code, maybe an abstract or a name, okay, they obviously we then have to provide an override, right, of that, and either they can prevent their own implementation or just call that function. So that's that. We're going to go to example 5, okay, example 5 5 dot dot, okay. Now in this example 5 dot dot, we are going to call in we're going to go a little bit, should I say out of bound? Yeah, let's say out of bound, because here we're going to be making use of a package called UUID, okay. So here we're going to implement equality with mixins, right? That's why we are going to use the the UUID package available on pop dev, right? So if I try to bring in a new window here, and I try to go to that pop, or you can just, let's just say pop.dev, okay. And we haven't actually talked about this pop.dev, because this pop.dev is actually an important repository for all Flutter packages, okay. So it ranges all Flutter and Dart packages. So you have some Flutter favorites, Cloudflare Store, Geolocator, the block library, from most popular packages, percentage, float, Flutter charts to top packages, Shimmer, Flutter easy loading, equitable login. I mean, you have so many of them. So these ones up here are mostly Flutter packages, right? You can use them, all are available on Flutter. And then when we come to on to that, we have Dart packages, right? So we have path, convert, XML, Flutter gen. We have plenty of them, so you can explore your wall here and try to get. So now the package I'm going to show you that we're going to talk about is UUID, okay. So this is it here, UUID. So UUID, you can see here, it's the name, you can see the version, okay. If I try to hover here, you'd say it's version 4.33, and this is that's Flutter available on Android, iOS, Linux, Mac. So this is basically all what you can get about the package, or the infos, how to use it, how to add it, right? Because to be able to add it, we need to go to our pub spec and say dependencies this, or we can say, we can go to the installing, okay, to the installing tab here, and if we are to use that, then we have to say that add UUID. So we are going to copy that, and that's what we're going to use. So an alternative way, if we're using Flutter, then we need to use this Flutter pop add, or you can do it manually by directly going to your pubspec.yaml and adding this line of code under your dependencies. either to your Flutter or your that popspec.yaml as it says here. So aside that now, once that is done, then we cannot copy this, we cannot import. So without further ado, let's go to it and let's come here. We're going to cd a little bit out. Okay, I hope I get that right. Cannot find popspec.yaml. I guess we'll have to open on well popspec.yaml. It's available. Let's open in terminal, and then we'll paste this here, and then we'll add that pop add UUID. Then we see that it resolves and goes to fetch the popspec, and that now has been added. Okay, so now we cannot freshly use that. So if we check our popspec.yaml, okay, if we check our popspec.yaml under dependencies, we can see that we have it installed here, UUID. Okay, so that was so much of intro. So let's go ahead. So we're going to have a main. So mixin has identifier. Okay, now we're going to say string get ID. Okay, and then what we're going to do is that we're going to provide a way of this mixin doing the comparison to check based on the UUID or based on this ID. Okay, so we're going to override nope, just going to override the bool, so operator. So what we're trying to override here is the equality. Okay, so we're trying to override the equality, so we're going to say the operator equality that we're going to be comparing against another object, which is going to be called order. Okay, should be, if it is identical, so what we're going to be comparing here is the this and all of this, the this and then the order. So I'm going to explain what the identical actually checks. Or if the order has identifier and the runtime type, so we're checking directly for the runtime type, is equals to the this, no, is equals to the order, yeah, the order runtime type, and the ID is equals to the order dot ID. Okay, so basically this is what we're saying. This identical here is just to check whether two objects references to the same, whether to check if two object references are to the same object. So basically all what just that means is that this identical checks in memory if this identical checks this actually can go away. This identical checks in memory if this and other are like coming from the same location or are stored in the same memory location. So that's just what it's checking. Or we make sure that this order is of type has identifier, and okay, the runtime type is the same as the runtime type, and then the ID is the same as the ID. So basically this is what we're checking, the runtime type and the ID. So then now we can go now ahead and create a class person. I think we've created a lot of class persons today with has identifier. Okay, it has an identifier, we'll provide a missing override, and we do the usual dance, right? So that's a getter, and for us to not break the contract, we can turn this into a final property, because we are going to provide that only when it's going to be used. So okay, so we're also going to have a final string name final int h, and then we can bring that in here So we're going to say required this.id, the name, and then this.age, and then that. Okay, so there's that. So now we're going to come down to this main property, this main function, and say final uuid1. Okay, we're going to say const uuid. Okay, so at first we could do this uuid uuid. That's still important, right? Yeah, at first we did this uuid version. I think I'm going to go with the version 4. We need better version 4. uuid version 4. Okay, this is not needed. Okay, and I'm going to duplicate this and say uuid version 2, still using the version 4. Okay, so that's all. Okay, so to be sure what this does, let me just do this, and let's go back to our Mixins folder and say example 5. Okay, that's an instance. Should we say we have to generate? Okay, so set that generate. So we now get the string. So that's nice. So now what we can do here is that we can create two persons. So we can say final person1 will be equals to person. Okay, and we'll provide each, let's just say 20, and the name, let's say Austin, and then I think I'm going to put this ID the first. It's going to be uuid1. Okay, so now I'm going to duplicate this and say person1 again. Okay, and just change this to lowercase a. Okay, and then we're going to create a person2. So this is going to be, let's close this out. This is going to be person2. Okay, and this is going to be uuid2, and still with the Austin. So we are going to write down some couple of if else statements here. So the first section will be comparing if person1 is equals, if person1 is equals to person2. Okay, and then we're going to print something here and say person1 is person1 and 2 are equal. Yeah, let's go with something like that. And here we're going to print person1 and 2 are not equal. So we're going to emphasize a little bit on the not equal, and we're going to print the delimiter here. So we're going to have this here. So I'm going to copy this and paste this about twice. Okay, so let's say here 1 to be able to see, 2, and then 3. Okay, the next one, now we're going to compare person1 and person1 again. Okay, person1 again, and we're going to person1 and 1 again are equal. Okay, and these are not equal, and for the last we're going to compare person1 again and person2. Okay, so we're going to say person1 again and person1 again. Now you need to take note that, like I said, right, this is going to do a comparison based on the UUID because that's what this has identifier is doing. Okay, it checks if they belong to the same memory location and or if they are pointing or referencing the same object in memory. Then we are checking if the order is oh we're checking if the order is of the type has identifier. Okay, then if it's of this type has identifier, okay, that's fine. Then I will now check the runtime type if it's equal to the runtime type. So if we had to create a person a dog class, okay, this will actually fail because we'll be comparing a person and a dog runtime type, right, or the instance. Then now we compare on the based on the ID. Okay, we're not comparing based on the name. That's why I provided this case where the name it's a lowercase name, like it's a lowercase name or it's an uppercase name. But let's do this. So let's run this code. So say example 5, and you can see that here for the first case, person 1 and person 2 are not equal, right? Obviously, let me bring this down a little bit so we can see clearly. So obviously person 1 and person 2 are not equal simply because their UUIDs or their IDs are different, right? So obviously they have to be taken from different reason why the IDs reason why they are not equal. And we come down to the second case to compare if person 1 and person 1 again are equal. Of course they are equal simply because um their IDs are the same. Okay, talk less of the name. The name isn't an issue because we're comparing them based on their runtime type IDs and if they are referencing the same object in memory. So regards to that, so we have now a last comparison where we are talking about comparing if person 1 again is the same as person 2. Okay, so and we can see here that person 1 and pers- person 1 again and 2 are not equal, obviously, because they have different IDs or UUIDs. Okay, so that was that with mixins, learning about mixins, importing or bringing in that package. Okay, so you should go ahead and practice along with this, and yeah, you'll get familiar with it. So don't forget to like, share, and subscribe.